Here is example for integral using substitution method. This example is very important. Find the integral from 0 to pi of the given function, which is 3 cosine square of x sine x dx. If we look at the whole situation here, you could capture cosine x, and we will equal u to cosine x. It's no problem with. Then we could find the derivative, because I need to find a term to substitute for sine x dx. We need to substitute for sine x dx as we substitute for cosine. So we equal cosine x to u, then the derivative of left side with respect to x equals derivative of right side. Derivative of cosine is negative sine. And now we could cross multiply, then du equals negative sine x dx. Remember, I need to substitute for sine x dx. So just divide by negative both sides. So sine x dx equals, when you divide by negative, will be negative du. Now we go back to the function here, the given integrals. So integral, set the integral symbol here, and don't write your bounds now, because it will be different. This bounds for cosine x, for x, but the new bounds will be for u. So hold it, we need to figure out the new bounds. And now we start to substitute for the function. So cosine square will be u square, remember. And we could kick out 3 outside. And then sine x dx will be negative du. We set negative over here, and here's du. This is the new function. Easy and simple to integrate. Now we're looking for the new bounds. To find the new bounds, we need to plug it in 0 and pi for the value of u. So here is u1. It will be cosine 0. And as you know, cosine 0 equals 1. And find u2. u2, we plug it in pi. So cosine pi equals negative 1. So the new bounds will be, for 0, instead of 0, replace 1, and replace, instead of pi, replace negative 1. Something missing. Look at this, negative 3 integral of u squared du from 1 to negative 1. Does make sense? No, I heard you. So we need to switch to start from the minimum to maximum. If you switch the symbol, negative 1 down and 1 up, this is our bounds. And here is the function u squared du. What happened here? We have to change the sign. If it's negative, it will be positive. And if it's positive, it will be negative. So it will be positive 3. Now we start to do the integral. The integral of u squared will be u to the third, add 1 to the exponent, divide by the new exponent, 3. Add 1 to 2 will be 3, divide by 3. And don't forget that we have 3 outside. And our function bounds from negative 1 to 1. So now we could find f of 1 minus f of negative 1. F of 1, you plug it in 1. 1 to the third is 1. And 3 cancel 3, it will be 1. Minus, you substitute for negative 1. Negative 1 to the third is negative 1. And 3 cancel 3, so it's negative 1. 1 minus negative 1, it will be 2. So the answer will be 2. Now, we need to prove that we are right using calculator. We could use the calculator. Follow me here. So go to y equals and type your function that you want to find the integral. And it's 3 cosine square prefer to open parentheses, set your cosine, and then x, close it, and then close again, and it's a square. Could be a square. Yeah. Square. Okay. Times sine x. Sine x, it's sine, and then x. So this is the function that you want to integrate. So to find the integral, press second trace. Go to 7. Click 7. Make sure before you do that, press mode, and make sure that you are in region system. See the blinking one, region? Set enter. Go back again to second trace and repeat the same. Make sure that the function will be graphed properly. And then the lower bound will be 0, as you see, 0, enter. And then the upper bound will be pi. Second, pi, enter. And the integral result is 2, as you see.